Today we're going to talk about expanded notation. A number can be written in expanded notation by writing an expression that shows the sum of the values of each digit. Well, sum means addition, right? The answer to an addition problem. So we're going to write these values today in an addition problem. Let's break it apart. Write 4 and 925 thousandths in expanded notation. Well, what's the value of this 4? It's worth what? 4 ones. What's the value of this 9? That 9 is worth 9 tenths. The 2 is in the hundredths place. That 2 is worth 2 hundredths. That 5 is in the thousandths place. That 5 is worth 5 thousandths. This is the expanded notation, or one way to write an expanded notation of this decimal here. Now, if I were to add all of these up, what should I get? I should get this number again. I'm not going to do that because that's going to simply get me back to my original number and undo my work, but I can see now the value in the ones place, the tens place, the hundredths place, and the thousandths place. Let's continue with problem 2. This 2 is in the tens place. That 2, this first 2 is really worth 20. That 1 is worth 1. That second 2 is worth 2 tenths. And that 7 is worth 7 hundredths. Again, if I were to add these up, I'd get back to our original number. This expanded form or notation should be something that you're kind of familiar with. Just like in the past, you may have written 325, noticing that that's 300 plus 20 plus 5. Similar idea. We're looking at the place value. Now, if I were going into a bank and I wanted to tell them some information, I might tell them how much of each denomination I want. Meaning, I want 2 $10 bills. I want one $1 bill. I want 2 dimes. I want 7 pennies, if I wanted to be very specific. Sometimes we do that when we go into a bank. We're very specific about the amounts that we want of each denomination, each coin, or each type of bill. Here we're going to be specific about how much of each place value we're using. So we're going to write 34 and 29 hundredths in expanded notation, this time incorporating some multiplication. So I'm going to write this 3 down. That 3 is in which place value? That 3 is in the tens place. If I were to write this like I had those above, I would have written 30. Well, what is 3 times 10? 3 times 10 is 30. I'm going to add that to the next place value I have. The next place value I have has a 4 in it. What's the place value of that 4? That 4 is in the ones place. Well, 4 times 1 gives me a value of 4. I'm going to write a little example. Like last problem, here we would have 30 plus that 4. Okay, let's move on to the next place value. Again, I'm adding because expanded notation we've written is a sum of the values of each digit. Here I have a 2. That 2 is in the 10th place. So I'm going to multiply 2 by 1/10. 2 times 1/10. If I were to add that like we did in our last problem, 2 times 1/10 gives me 2 tenths. Our next place value is the 9. that 9 is in the place value of the hundredths, so I'm going to multiply it by 100. If I wrote that down like our last problem, 9 times 100 gives me 9 hundredths. Now this part doesn't really have to do with this problem, I just wanted you to see how they would relate to each other. So we have 3 in the tens place, 4 in the ones place, 2 in the tenths place, 9 in the hundredths place. And if I multiply these, I'd get a value of 30, I'd get a value of 4, a value of 2 tenths, and a value of 9 hundredths. We can use that place value to show that expanded form. Let's look at this one here. Write 2 and 754 thousandths. So I'm going to multiply 2 times, what's the place value there? 2 times 1. Well, 2 times 1 would give me that value of 2. I'm going to add that to the next place value, which was the 7. The 7 is in which place value, though? It's in the tenths place. Add that to the 5. The 5 is in the hundredths place. Add that to the 4. The 4 is in the thousandths place. Whoops. The thousandths place. This is expanded notation. This time we're multiplying by decimals. We're using multiplication to get our decimals. Is it absolutely necessary that I have parentheses here? No, because multiplication comes before addition in our order of operations. Is it easier maybe for me to see the grouping and how the 2 is in the ones place, the 7 is in the tens place, and so on? Yes, it's easier for us to see the grouping, and that's why I used it in today's example, but it's not absolutely necessary. So just to review, for expanded notation, we're using the value, the place value of each of the digits, and we're multiplying that place value by the digit in it. So here again, 2 is in the ones place, 7 was in the tenths place, 5 was in the hundredths place, and 4 was in the thousandths place, and that's how we were able to get our expanded notation.